We've been asked to find a Taylor series for g of x equals 3 raised to the x power, centered at x equals 1. And then we also want to find where it converges. And more than that, I want to know where it converges absolutely and where it converges conditionally. But we'll start, as we do, by taking some derivatives. So let's see, I have g of x is equal to 3 raised to the x power. First derivative, well, that's 3 raised to the x power times the natural log of 3. Second derivative, well, that's 3 raised to the x power times another natural log of 3. Second derivative, excuse me. Third derivative, well, that's 3 to the x times, well, another natural log of 3. And I think I see what's going on here. When I take the nth derivative, I'll have a 3 to the x times the natural log of 3 raised to the number of derivatives, the order of the derivative, so natural log of 3 to the n power. All right, well, I'm centering my Taylor series at 1, so I'll need to evaluate that at 1. So I have 3 times the natural log of 3 raised to the n power, and I'll be dividing that by n factorial. So those are the coefficients for my Taylor series. So I could go on and write that down. All right, there is my Taylor series. We could write out the first however many terms we felt like, but for right now, I'm just gonna let it have this nice, happy series representation. And now I wanna see if I can find the interval on which it converges. And I'm gonna use the ratio test, which if you've watched the videos I made before this one is not a surprise. I've done the ratio test a lot. But even if I wasn't in the habit of using the ratio test for power series, for Taylor series, that factorial here is going to tip me off that it's a good idea. So let's take a limit as n approaches infinity. And I'm going to need to replace this n's with n plus 1s. The variable expression will be an absolute value. And now I need to think about multiplying by a reciprocal of the nth term. And that should have a plus 1 on it, right? That's still the n plus first term. And there we have it. All right, so I just need to see what cancels. There's a lot to deal with here, and there might have been a more efficient way of writing this down, but this will get us through it. The 3's definitely cancel. So in my next step, I'd have a limit as n approaches infinity. No more 3's, and let's just see what else happens. So I have a natural log of 3 to the n plus 1 divided by a natural log of 3. That's going to leave me with a natural log of 3 on top. N factorial over n plus 1 factorial will give me just a n plus 1 on the bottom. And then I have the absolute value expression here, and there's just one more of those on the top than there is on the bottom. So I end up with a natural log of 3 times the absolute value of x minus 1 all over n plus 1. I'm not really happy with the way that looks, so I'm just going to rewrite the bottom a little bit. But regardless of that, the variables on the bottom, everything on top in terms of the limit is a constant. So as n goes to infinity, I get 0, which is always less than 1. So now I have another Taylor series that converges absolutely for all x. Oh, after you've watched this video, I think it's a healthy idea to write out the first so many terms of this, so maybe 5, 6, or 7 terms of this Taylor series, but that's it for now.